Good evening, guys. Thanks a lot for joining. I'm really excited to start another meetup. I still have some presentations and some intro slides to go on, but we have really exciting conversations today around observability, EKS, AWS, and whatnot. So yeah, just a small intro from my side, and I would stop speaking. So first of all, thanks a lot, AWS, for providing this beautiful venue. And just a small reminder, let's take care about the hygiene and housekeeping stuff. Please do not forget whatever things or belongings you have here. And today's sponsor is Rendoli, and they would be presenting around observability with EKS, and they would share more about their platform. Uh, Photos. If you are clicking any pictures, we love seeing them. We love hearing your feedback. So feel free to scan the QR code and let us see what you are clicking on the other side. A small announcement, this user group or the meetup thing is running independently from CNCF. It's just a small disclaimer. And whoever you see from our team are volunteers. All the communities and organized things are led by volunteers, and we don't have any monetary equivalent included in it. And yeah, in this website, you can get more information about certifications, promo codes, Kubernetes exams, and some exclusive discounts on some platforms. We have some upcoming events as well, running worldwide. You might see Australia, UK, India as well. And the QR codes, feel free to share your feedback, how you feel, if you need any improvements, if you have any specific topics you want us to share, or if you are willing to speak here and share your voice and share your insights, we love to hear from you. So please scan all those QR codes and let us know your thoughts. All right, and towards the end of the session, we have quite a good giveaways. You might see those 2 books. So plus we still have some more giveaways. So we have a small quiz towards the end. So stay tuned. And without talking any further, I would now invite Preetham from AWS team, and she would be discussing around observability and how AWS enhances in the cloud native monitoring space. So please, a round of applause for her.
Hello, can you hear me?
Yes.
Okay. So first of all, good evening, everyone, and thank you for joining for this event. I'll be talking on observability for Amazon EKS, and I'll give a brief introduction about myself. I'm Preetham Rebello, Senior Technical Account Manager here with AWS. I've been with AWS for past 3 years, and I'm also part of containers technical field community. So here at AWS, we do have specializations, specific different domains, and I'm part of containers DFC. We'll be talking about observability for Amazon EKS, and I don't know if you all know, Amazon EKS is a managed Kubernetes platform which is offered by AWS. So this would be the agenda for today. So first we will be talking through what are the best practices for observability. Then talking about what are the AWS observability tools which we'll be covering. And then I'll also go through some of the open source observability tools which are available. And then we will have a demo given by our partner, Randoli, regarding to the observability platform which they offer. So to start with, one second, some glitch. Probably I'll just stand here. Okay. So what is observability? And I'm sure that most of you folks who are here must be knowing what observability is here, right? What observability means. But just so that we are all on the same page, we will go over the definition again, right? So what is observability? Observability is much different than our traditional monitoring, right? So it can be defined as, a measure to understand a system, right, internally based upon what external outputs you kind of get, right? And it's very important to have your system more observable. And the reason for that is the more your system is observable, it gives you, a better understanding of the system, helps you in troubleshooting the problem, detecting the problem, finding the root cause, and even fixing the issues, right? So that's the reason you need to have your system more observable. Your system can be like either more or less observable, but if our system is more observable, then it helps you with the visibility, right? Which helps you on the operational side as well as the real-time troubleshooting. In addition to that, as you see right on the right-hand side, it helps you around, your business goals as well. The more observable your system is, and more performant it is, it gives you a better customer experience, right? And a better customer experience is typically, in turn gives a better revenue. So that's the reason that observability is something which is very important to have it in your system. Okay, so these are some of the terminologies which we will talk, and then you'll understand, right, like why I'm bringing this up, because there are some definitions which are depend upon, understanding this. So what is black box and white box monitoring, right? So there are things, right, like what's broken in the system, right? And then there is why things are broken. So most of the things when you see like a black box monitoring, it's more of the systems, right? Which has happened due to some issue in the system. And for that, you need to, really understand, like, have the internal knowledge of what's going on in your system. Because once you have that information, you can determine, right, like what is the cause. I can give you one example, right? For example, you can say, right, in your Kubernetes, my API server is running slow, right? So that is something probably is like a black box monitoring where you're seeing some outcome. And then when with your white box monitoring, like inside the system, you come to know that your etcd database, it has a high write latency, right? So these are all interrelated. And for you to determine like what is the exact issue, you typically need to have both this monitoring in place. So how can you have this, right? Like how can you have this white box monitoring in place, right? And that's where the instrumentation comes in place. Now what is instrumentation, right? So instrumentation is the way by which you can have the white box monitoring on your system typically, right? And this is something which is events which are provided from your code. I'll try to give you one example, right? So for example, think that you're standing near a road, right? And seeing a car which is going on a freeway. By seeing the car which is moving, I can determine, like, I can guess, right? Like what can be the speed, right? So it's just my guesswork. But think like there is a cop with a radar gun, right? And he's trying to gauge the speed. He would get like near accurate speed, right? With that gun. But now think about the person who is on the driver's seat, right? Who is driving the car. He has all the information about that car, right, in his dashboard, like what is the speed of the car or what is the tire pressure, and all the metrics, right? So he has all the information what's going inside, and that typically is kind of information which you get within the system, right? So see how different it is, right? Like something which you are kind of imagining or guessing it from out versus what is given out of your system, right? And that is very core for you to get that kind of information, to understand your system more and make your system more observable. And having this kind of data really helps, right? Like as we already mentioned, right? Having more insights kind of helps you in debugging, troubleshooting, or doing your design validation, and in turns, have a faster, improved feature velocity, right? Because you have the right data to make the right decisions there. So now we spoke about instrumentation, we spoke about observability, right? So now the things comes is like, but how do we make, right, microservices and serverless more observable? So as you know, right, like microservices and serverless, like most of this are like ephemeral, right? Uh, they are probably short-lived, and in case if there is an issue, right, or performance issue, it's very difficult for you to determine, right, like what went wrong. So it's very important for you to have all right kind of data in your system. The other thing is that how do you, have this like white box monitoring in this system so you get the information from it. Okay, sorry, I think it went. So to answer that questions, right, we will go over some of the best practices for observability. So this is the first principle, right, which says that all your observable system, right, should emit these events. So these are the three events, right, which are the core foundation for observability. So one is the logs. I believe like each one of you must be knowing, right, like what are logs. Then the metrics. Metrics has been there for like long time, right? This is the traditional monitoring, like time series data, what you get out of your system. And then traces. So traces is something which, you can determine based upon the dependency of the service, right? Like as we spoke about, like when you have a lot of microservices, talking to each other, you have distributed systems, right? So it's very important, to see how your transaction or how your request has flown through the system, right? So that's when traces helps. And I do have slides which, talks in detail about each of this, the foundations, like these pillars, which are, very important for your observable system. So the second component is that all components should be instrumented. What does this mean, right? So when you talk about microservices, right? The insights, what you get out from your system, that should not be only limited to your service, right? You should have the ability to get the insights from your pods, from your nodes, from your cluster, as well as the underlying infrastructure. And and also like from your clients, right? Like what you're using to get the systems. So having the end-to-end knowledge of all this information is very critical or very, important to help you in getting those metrics out of it. The third one is instrumentation, right? Like having this data generated from your system. This should not be like, like not opt-in, right? Like it's not like good to have, but I would say this is must to have for all of your systems. And it should be not hard to do, right? So in that way, most of the organization or most of the applications can have this, embedded or have this as a part of your system, right? Or part of your applications. So these are the three main, I would say, best practices or which are required for the observability. So since now we were talking about like very generic terms, right? Like what is observability, what is instrumentation, right? So that was just how things are. But now we will be talking through about what are the tools or what are the services which AWS has to offer, right? So and which aligns to all these three pillars, right? Like I did mention about logs, I did mention about traces and then metrics, right? So AWS has this CloudWatch. So AWS CloudWatch is a native monitoring service, and it's typically for all the AWS services. Uh, Of course, right, like it's been used for EKS as well. So you have like AWS logs typically, where you can get the logs from the system, and then you have option to do analysis or get insights about it. Similarly, you have CloudWatch metrics to monitor the system. You can have alerting mechanism configured on that. And then extra traces, right? So I did briefly spoke about traces, like how traces are important for you to understand the flow of your system, right? So in the same way, AWS has X-ray, which is a service where if in case your application is instrumented with the X-ray SDKs, then you can get all those metrics out of your application, and it can be viewed in the X-ray as a service. So these are some of the services which AWS offers. So these are the main things, and then you will further see that these are the tools, right, which go around, right? So I did mention that it's very important for you to have your monitoring or observability across all your platform, right? Like at the infrastructure level, at the application level, and then you have something called as synthetic monitoring. So synthetic monitoring is another interesting topic. It's typically more of how you can like a simulate a user interaction, right? For example, if you have an e-commerce website, how would you simulate a user behavior, right? Which can give you the data, how the response time was, and get metrics around it, right? Or for example, you wanted to check like how is the behavior of your website or e-commerce website across different geographic, right? So you can have like a two agents. One you can maybe initiate it from Canada, one from India, and then see what is the latency, how you get the response. So typically that's how you use synthetic monitoring. It typically also can be used, to monitor your application, like whether it's up and running, whether it's performing, have a good response time. Like you don't really have to wait for the user to log in and then complain back to you and say, right, like the application is not running. So that's something which you can, get using the synthetic monitoring. So now we will talk in bit detailed about like what traces are. So traces, as we spoke, right, like in microservices or in like a distributed systems, there are multiple components for which your request really have to go through, to complete the workflow, right? So, and it's very important for you to determine like at what point, what is the response time or what is the latency. So traces is typically, mapping of this. So if there is a request going along from point A to point B, right? Like going from A, B, C, D. So the way it flows is the way the data is collected, it like it will record the data from A to B, right? Like how much time it took to go from A to B, like whether any errors or any other components, like what it has to, that is recorded. B to C, what was the time. So in that way, you have the whole map. And this kind of helps you to determine or pinpoint, right, in case you have any issues with any of your application, then exactly where was the issue, right? Like, it's very, like, for example, you have a website, right? And if I click on one of the page, I get a response like in maybe 2 seconds, right? But that doesn't really tell me like what exactly happened at the back end, like how much time it took from your web server to go to your application server, or maybe the service, right? And how much time it took to go to the database, right? So all these things are captured in the traces, right? And this is very important, for you to troubleshoot your applications or figure out the performance bottleneck. So I briefly mentioned about the AWS X-ray service, and this is typically used for you to get the information, right? The traces, and you can analyze this traces in this X-ray service. So we already mentioned briefly, right? Like what are the benefits, right? So it's analyze, it debugs, right? Helps you to find what are the performance bottlenecks. So in this way, this is like out of the box service which you can use if in case your application is instrumented with X-ray SDKs. This is just an example of like a pictorial view of how it looks, right? As I mentioned, we have different microservices. It does captures how much time it takes, to go from one point to the other point. And then if in case there are any issues, fault or errors, those are also captured along the line. So we covered traces, metrics, again, time series measurement. I believe you all must be knowing about it. This is the base, right? Like here it just show you what is the CPU utilization. And in AWS, we can use like CloudWatch container insights to get all these metrics, right? You can get information about the pods, the memory, the CPU utilization, like the network, similarly for the nodes. And what you see is like at the base, you see, right? It's Kubernetes, you need the agent. And with that, you can have the metrics and the logs given to that CloudWatch container insights to get additional information about it. Yeah, this just explains you how the agent works with CloudWatch to give the details. This is if in case you have like a Prometheus SDKs, right? Like if your services are instrumented using Prometheus, then you can leverage CloudWatch agent for Prometheus to get all those insights. Okay, so now we will move to logging, but like I just take a pause, right? And I just wanted to see like, whether what I'm talking you guys are following or I'm making your board following that.
Yeah, got a question. How we gonna instrument serverless components?
Serverless component. Good question. I'll check, but so in instrumentation, you have like instrumentation, and then you have something called as auto instrumentation also, right? So auto instrumentation is typically like used when you don't have to make any changes into the code, right? It sits outside your like application, and then inspects the calls which are made, and based on that the metrics are derived.
And just a quick one, because you said serverless. So on the serverless side, if you're looking at specifically Lambda functions, in which case Lambda functions will have direct integration with sending the metrics to CloudWatch, from where you can then kind of gather more insights. So there are native integrations available when it comes to serverless functions. If you're looking at serverless containers, which is ECS Fargate, then it pretty much kind of aligns to a lot of what you're seeing here, although it's Kubernetes focused. But a lot of even the third-party tools, they will probably provide support for both. And specifically for Fargate, the important piece, because it's a serverless compute engine, the piece to understand is that there is no daemon set per se that runs on it, because you can only run it as a sidecar. So you need to make sure that the tool that runs on top of Fargate runs as a sidecar and not as a daemon set. So those are some nuances to take care of when you're looking at whether serverless functions or serverless containers, and then how you want to instrument that.
Okay, thank you, Carl. Yeah, okay. Any questions? Okay, now I'll start asking you questions actually. Okay. Okay, I believe, right, this slide requires no explanation. Everyone knows, right? Logs, they are crucial, very important in troubleshooting, and it's typically like based upon the time, right? That's how it's logged and very helpful in troubleshooting. So how we spoke about how metrics are captured, right? In similar way, the CloudWatch logs also are sent through the microservices. Here we'll touch upon Amazon EKS, right? So as you know, right, Amazon EKS is a managed AWS service. So the control plane is managed by AWS. So there is a mechanism for which the control plane logs are sent to the CloudWatch. So it's disabled by default. But when you have Amazon EKS clusters, you can enable it, and all these logs would be then available in CloudWatch logs for you to analyze, or in case if you need to get more data. So that's how it's captured. Similarly, you have an option to get the logs which comes from your pods, which comes from your nodes. You can use the tool, the Fluently, and then you can configure the destination where you want to send out the logs. So that's another mechanism for sending the logs from Amazon. Yes. Okay, so I think now the interesting. So we will talk about the open source services, right, which are available and which are offered by AWS. So this is first is the Amazon managed service for Prometheus. Many customers, right, they do use this open source tools, right? So for example, if in case you are using your self-managed Prometheus servers, then you have to take care of the Prometheus as an application. You have to make sure you have the system highly available. You have to make sure that, the scaling of that system is in place, right? And that is the reason, right, this is all offered by AWS. So if you go for the managed service, then what you have to do is you have to configure the workspace and then have a Prometheus scraper in your EKS cluster where it will scrape all the metrics and send it to the Prometheus servers. So it takes away the overhead of, the Prometheus server management, typically from the customers. And in the same way, you have AWS managed Grafana, which is used for visualization. Again, the service is managed by AWS. You can use the data source as AMP, right? That's Amazon Managed Prometheus, or you can use CloudWatch or other third-party sources to get the data and then have the visualization, please. Have any of you folks been using this? Yeah.
Just one question. AWS managed Prometheus, these are not Prometheus servers. So it's stored by AWS and you implement part of the Prometheus API, but to the best of my knowledge, not all of it. So if I want to consume it using Grafana, that's fine. But if I want to consume it using something else, it may or may not work. That's my question.
Like EMS would not work like.
No, my point is that these are not Prometheus instances hosted by AWS. The API, the Prometheus API that AWS managed Prometheus support is a subset of the Prometheus API.
Okay.
Correct me if I'm wrong, but to the best of my knowledge, that's how it is.
Yeah, you're absolutely right. I see it on the description page.
So it's the infrastructure, right? The underlying infrastructure, what is required for Prometheus, it's something which is managed by AWS.
Yeah, it is managed by AWS, but it is not. It is not a Prometheus. It's not 100% Prometheus like you would go and deploy it in.
Oh, like okay, yeah. So which you would install on your EC2 instance or on
whatever,
right?
whatever you install.
No, absolutely right. Because when you move towards managed services, right, that's how you have that control, right? The limited control what you get, right? You just have the access to maybe create the workspace and then go from there. But if you want to have an end-to-end control on the server with configurations and everything, then self-managed Prometheus would be the way to go. Yeah,
Sure. So, sorry. So, I know what is CloudWatch actually? Is it just some kind of endpoint that you can supply it with event streams, or does it somehow take measurements on your services?
Actually,
CloudWatch, what does it do exactly?
so CloudWatch, CloudWatch is the AWS native service, right?
To stream between the CloudWatch. Check the credit score and the amount of the credit card. It's very expensive. But if you want to stream some data, this analysis later, it's always better to stream it to S3 and build on the system on top, just to save your money. The same tools, similar experience, a little bit different experience, but similar, right? But more close to best practice.
So like, but my question was, what is CloudWatch exactly?
Which this is very expensive, but very fast. But very fast. I got, come on, it's expensive. I see my monthly bills and I pay $2,000 for CloudWatch only.
Yeah, but there's also now tiered pricing and those other areas which are greatly changing the cost structure. So you've got to take a look at those also in terms of how, but yes, we've got that feedback. And that's exactly what the product team is working on how do you bring in tiered pricing for CloudWatch to help reduce, but yes.
Yeah, but it's still nice.
Yeah, you could, that's why you can shift it to S3. Yeah, but again, that's not, this question is not that. His question is what's CloudWatch,
Yeah,
so let's get that.
Okay, so I'll tell, so it's a managed service, right? Typically, it's a monitoring service. That you get to see the metrics which are emitted from the services.
So those metrics are basically like we supply the metrics to by event stream or something to CloudWatch. It's like CloudWatch is not going to do anything by itself.
So there are some AWS native services which directly sends also events, like
Okay.
like they're integrated, right? Because it's a native service. But like when you spoke about EKS, right? In terms of, I'm talking about EKS,
Okay.
you have an option, right? Like you can enable the control plane logs to go to CloudWatch. So you have a click of a button where I say, okay, I want to send my control plane logs to.
So Amazon can create those events and send it to.
So those are generated, right, as a part of your application. Like your Kubernetes cluster generates events, or your pod generates like logs, right? So that's a mechanism. It's a destination where you can send your logs. And then on top of that, you have like insights, right, where you can analyze them as well. I don't know, just time check. We are good, right? Only 5 minutes? Oh my God. Okay, so this is just like a slide which talks about like how you can have AMP, right? The managed Prometheus and Grafana. Typically, you scrape the metrics from the Kubernetes clusters and then have it remote write onto the workspace, and then you can use Grafana to visualize it. Okay. Okay, so I think probably I'll ask. So what is OpenTelemetry? You can tell.
And metrics and traces what we can send to some kind of OpenTelemetry collector. It can be implemented because it's just standard. Yeah, because it's just standard, anyone can implement it. For example, I don't know, Skywalker, the very famous Apache Foundation project, right? For collecting servers, right? And I believe you want to tell us about something where you implement the same functionality as AWS, like a native service, right?
Okay, so you were spot on. So yeah, OpenTelemetry is a standard, right? And it was very important to have some kind of a standard or protocol, right? So in that way, all your observability platforms, right, what you use, you can leverage them, right? Like you don't really need to change the instrumentation of your application if you change, if you want to change your observability platform. So OpenTelemetry it's open source, right? It's it's vendor agnostic, and then it provides you that framework. I would say it's a framework where it tells you, how you can emit that signals, typically your logs, traces, and the metrics, right? And that can be leveraged. Now, and then on OpenTelemetry, we have something called as A-dot, right? So OpenTelemetry typically refer as OTel. This is A-dot, and what is A-dot, right? So this is a secure, production-ready, AWS supported. This tool which is built from OpenTelemetry, and it it supports many of the AWS services. So that's how it's still used. And like it's the same functionality, right? It provides you the SDKs or the libraries which you can use to instrument. It provides you the collector which you can leverage to collect the data and then send it to the exporter, right? So this is how your AWS distro for OpenTelemetry looks like. The main thing is what you see is receiver, processor, and exporter. Those are the main components. So receiver is typically to receive this data, processor is in case if you need to process, and export is to export it to destination. So your destination can be any thing, right? Whether it's CloudWatch, X-Ray, or Workspace. And similarly, in case you have some other third-party, monitoring system, and then the collector, you can use the same collector and have different pipelines configured, right? The way based upon what you are collecting and what you want to send. So this typically how it looks like.
Question about this diagram. The export to AMP, is it only Prometheus protocol, or do you also support OTel for metrics? Can be done in both ways.
Yeah, it can be done in both ways.
It's a question of what
as well.
Amazon managed Prometheus supports. I don't know what it's required.
So you want to know whether it supports OTel as well.
Yeah, as line protocol.
That is for exporting it out.
Yeah. Remote write is using Prometheus line protocol.
Yeah, that is specific to Prometheus. But you want to know if you can use OTel to do the same thing, right?
Yeah.
Yeah, I don't know. I like to check it and then. Okay. So again, same thing, ADOT, it's just that it's been, deployed using EKS add-on. Anyone knows what is EKS add-on, like anyone using Amazon EKS? So, okay. So EKS add-on is typically, whatever tools you are using support the EKS cluster. You have a question? You have answered. No. You want to know what is add-on, right? Okay. So I think, yeah, I'll explain. So EKS add-on is typically, providing you the mechanism, the tools where you can easily install it, manage it. So in that way, ADOT is something which you can install with a single click and then go ahead and manage its life cycle typically.
Is the add-on managed in the way EKS is managed?
No, not in that way. Manage is like just providing you the ease of installation and upgrade. And this is my last slide, just to give you like the snapshot of like what we discussed, right? Like what are the different services, what is offered. We spoke about instrumentation, right? If you take like the bottom-up approach, and then how you have different agents, how you can have different SDKs, and then how the observability is built on top of it. On the right hand side, you have the native services, and then you have the open source services which are offered. But this is the whole stack here. You have question? Okay, go ahead.
Slide here. So from what I understand is that there is a traceability for with X-ray, right? And so that's where we had the different nodes and we're looking at different metrics of like, okay, this is the speed and all that. So would like Cytochromatic complexity help with that detection of the performance bottleneck on top of already what's existing there, or is that a different can of worms? That could be a dumb question.
Like you want to understand that does that add overhead to the system?
Yeah.
To understand your performance, you need to do baseline, right? You can like a human, you can detect it's fast or slow, but for automated system, you need to do baseline. And at AWS, you have a perfect instrument for that. You can put all your metrics inside of OpenSearch. You can use anomaly detection on top of your metric and get automated align when something outside of baseline. Right?
That's like alerting, right? And then
This is one of the cases. We
Yes,
have got million of the cases.
got the answer, right? And then the other thing is, right, like for troubleshooting as well, right? When you see performance issues, then you can go and see like, oh, what was it that we said, right? You have a baseline and then you see what is the difference that happens.
But it's great. This is great too. You can check everything on the bottom of, I don't know, your database request.
Okay, so my section is done. I think I took more time, sorry about it. But please take some time, give the feedback. Would appreciate that. And thank you so much. I'll be around in case if you still have some questions. I would be happy to take that. And I do have one question which I have to respond back to you. I'll do that. Thank you so much, everyone. Yeah.
On time and stuck in traffic, and I'm I'm grateful for having me here today, and then also Preetham speaking before me, so she made my job a little bit easier by giving you guys a bit of an overview into observability in general, and then talking a little bit about OpenTelemetry. So I'll kind of start from there, and then I have a live demo. Hopefully it'll work. All right, so I'm Rajat. I'm the founder and CTO for Randoli. I've spoken at this meetup a couple of times, probably twice before, um, and been around Kubernetes for a while. And what does Randoli do? Very quickly, we have an observability product, well, there's an add-on to like a cost management. If anybody has heard KubeCast, who's heard about KubeCast? Yeah. All right, so there's an open source project called OpenCast. We actually work with the KubeCast team on that, and our cost product is based on that. And so anybody's interested from a cost perspective, but primarily, we are an observability vendor. All right, good. Now that we got that out of the way, let's talk about today's topic. All right, so. All right, so let's talk a little bit, about the observability challenges that people have with all the proprietary tools that are floating around, and then we'll kind of talk a little bit about OpenTelemetry because Preetham already kind of, broached the topic, so I'll kind of expand from there. We'll talk about some of the key building blocks in OpenTelemetry, some different instrumentation approaches, and then I'll talk about OpenTelemetry and Kubernetes. So OpenTelemetry is not limited to Kubernetes, even though it's a CNCF project. You can, if you're running applications on VMs, still fair game. OpenTelemetry and Kubernetes is, I'd say like, a very good experience because there's an operator that does a lot of auto instrumentation based on annotations and stuff like that. So it works really well in Kubernetes, but it is not just limited to Kubernetes, right? And it's not a MERN stack demo, so I stole a slide from someone else. I actually have a microservices demo written in Spring Boot and Node. So I'll show you guys that. All right. So I think Preetham already spoke about this. Let me see if I can make this a little bit better. Better? Okay, good. OpenTelemetry is currently arguably the most popular CNCF project. Lots of interest at KubeCon. And normally when you go to KubeCon, you have the project pavilion. I'm assuming a couple of you have gone to KubeCon. You have the project pavilion for all the CNCF projects. But this year in London, OpenTelemetry had its own booth, like in a separate. So that tells you the amount of interest in the project itself. It has boomed, and it has actually created a nice ecosystem around it. And people are looking at people are now, for example, some of the CI/CD vendors are looking at adding OpenTelemetry support, right, using the event. So there's it's a very thriving ecosystem. Okay, right. So let's talk a little bit about current observability challenges. Apart from most observability tools being expensive, that's a separate one. We'll chat about that separately. But
observability is expensive. Now I'll talk a little bit about, when we talk a little bit more about a product. But the current challenges are all these different vendors have different SDKs. So some folks actually are trying to switch from one vendor to another, and the biggest roadblock is the amount of custom libraries and custom ways of how this telemetry is extracted, right? Especially if you're, instrumenting the code, right? So this has been a bit of a pain point in the industry for a long time, and they ended up, working together. Datadog, Dynatrace, Splunk, Grafana Labs, Red Hat, smaller vendors like us, like people got together, they created a standard, and they ended up, you know, building a common way, establishing a common ground on how you're going to gather telemetry data, right? And then, so then where does the vendors come? I will show you that part in a diagram, but then the vendors can, take, once there's a standard way of gathering the information, they can do their value add further down the chain. So if you look at the OpenTelemetry project, you'll see contributions from all the different, especially the top observability vendors, and that's also why I think it's a very successful project. There's a lot of buy-in, and there's a lot of sort of brain power being added into the project, and it's come a long way since. I mean, if you tried this 2-3 years ago, a little bit wonky, but it's pretty solid, and I'll show you some stuff today. All right. So the different SDKs I talked about, that interoperability too, it's kind of similar to that. If you have a common data format, it's easy to write tooling. So, anytime we talk about standards, like, I mean, now, with the agentic AI, they're talking about MCP, agent to agent, right? A to A. All of these are there because then it makes it easy for people to add tooling along the chain. So that's another key benefit of OpenTelemetry, is that they are trying to have a standard, not just a common set of SDKs and stuff like that, but also a standard, because now other vendors or other third parties can add value on top of that chain because it is a standard out there. And then I kind of talked about this vendor locking problem. Without naming names, it is a problem, and sometimes people want. I think it's a good thing to have choice. Like, if you are, I mean, you're currently stuck with Bell and Rogers. I mean, it's not a good example, but just imagine you have 10 cell phone providers, right? If you buy a cell phone and that only works with Rogers, then you're screwed, right? So that's kind of what it is, actually, in a nutshell. It gives you that vendor neutrality. Today you're working with Datadog, tomorrow you can go to Dynatrace or Randoli. But that's the kind of like the power of the open standards, right? And then the operational complexities, it depends. I think there are some setups that are simple, some setups that are complicated, so I wouldn't want to talk too much about it. But especially if you're doing open source, though, it's a bit of a, you got to roll up your sleeves and you get your hands dirty. So maybe this is more relevant if you build an observability stack using in open source tool. But trust me, like, some people do it, and there are some benefits. So if you have some very large organizations, they actually build their observability stack ground up. Why? If you go to one of those other vendors, you're going to pay a truckload of money. So and they have a team of, I don't know, 10, 15 people just working on observability. So it works for them. So for example, just forget about observability, OpenCast, we work on that project. There are some end users who are actually contributing. Why? Because instead of buying a vendor product, they take OpenCast, and they have 7-figure cloud bills. And they have 10, 15 people sometimes working on it, because it's for them, they have the manpower to manage, and they have a customized solution, right? And most of the other vendors too kind of build on top of open source. So that is also another kind of, I guess a good way to think about it. Like, you would think like open source is like, like a poor man's version. Not really. A lot of the solutions out there is actually built on top of that foundation that open source provides. All right, so this is kind of like the main goal. I'm not going to read it. It's pretty obvious, right? And it's and regardless of because a lot of microservices are written in multiple languages these days. So you kind of want like a standard way of getting these things, and instead of some random language specific thing too, right? So that's also another nice aspect of OpenTelemetry. Instead of having, it's not just the proprietary vendor libraries, but also from a language perspective, right? Brings in a common structure. All right. So Pritham already talked about it. I'll just briefly mention. When it comes to OpenTelemetry, there's a couple concepts. You have this concept called signals, and then you have traces and metrics and logs. So if you look at any observability article, there people talk about the main pillars, right? Nowadays there's profiles as well. People talk about the fourth pillar. If you look at OpenTelemetry, there's events and profiles that are currently being developed. There's a pretty nice profiler, eBPF profiler, but I will, you can experiment with it. I believe, we also keep closely watching it. It's not super production ready yet, but they're building that. So that's to gather profiling information from applications. But the top three, everybody's familiar with, right? So events is like, sort of another category that's evolving. Keep an eye on it, and some of it is driven by the extension aspect of OpenTelemetry, right? So keep an eye on this space. It's growing, and it's a lot of good material out there. All right. So distributed tracing, I think Pritham already talked about this, showed the diagram. This is actually the same demo I'm going to show you guys. I just built a. I don't code much these days, so just that's the way to get some. What's that? No. So it's a way for me to have some fun. So I ended up building it. The sad part is the inventory service, which is written in Node, is crashing because of some issue with the connectivity to Mongo. I didn't have enough time to debug. I tried it on the Uber and gave me headaches because I can't read when things move. But others I would have got, and I couldn't. Eventually I put a UI in front of it too, because with OpenTelemetry you can trace from the browser all the way, or your mobile app all the way to the database, to whatever the backend system, going all the way through it. And because there's an OpenTelemetry library for React and stuff like that, I kind of want to show it to you. And then other middleware pieces have added support. So, for example, Kong, I'm sure the other API gateways do it, but they have added support to OpenTelemetry. So when it passes through the Kong API gateway, it adds a span. So because there are some cases where if you're debugging, right, suddenly your customers are saying, "Hey, I can't reach your service," and you look at it. I mean, I'm not seeing any logs in my service. Why? Because your service is all like can respond. Threads are all stuff. It's not responding. So the API gateway is timing you out, right? Or from the AWS load balancer, if you don't have an API gateway, or you put an load balancer in front of the API gateway, stuff like that. So, all of these ecosystem pieces are also adding support for OpenTelemetry. Pritham mentioned about X-ray and stuff like that. So the one thing I hope eventually AWS will change their mind. They don't have support for OpenTelemetry out of the box from the application load balancers. I'm hearing it's because of some performance concerns, because they're shared among applications. I mean, don't quote me on it, but that's what I heard offhand. But there are ways to work around it, because there's the X-ray header, and there's a roundabout way of getting it. If you can match your X-ray headers to the OpenTelemetry IDs, you can artificially inject a span. But I would like if AWS ends up adding support for OpenTelemetry, so that we can scrape relevant metrics, trace information from the load balances. So more and more vendors are adding support for OpenTelemetry. If you go to OpenShift, there's an OpenShift build. Pritham talked about AWS has its own OpenTelemetry. Yes, build of OpenTelemetry. So lots of vendors are adding, lots of middleware folks are adding support. Today I was actually talking with one of our customers about CockroachDB. They have added OpenTelemetry. So that's a standard way of getting that. Postgres had support, Kafka had support. So you can ingest all of these metrics in a standard way and build tooling and capabilities on top of it. All right. So just talking a little bit about traces. Pritham, did you already cover this part, the context propagation part? Now, okay, so I'll very quickly cover this one. So when you have a lot of microservices in this, when I hit the order endpoint, it what it does is it actually looks up something from product catalog, that does a lookup from Redis in turn, talks to the database, sends a message to shipping, sends a message to Kafka that actually goes to inventory. Now, if you want to debug this, you figure out what happened, you should be able to trace this. Right, in the past, we had a monolith, all the logs in one file, also written to disk. Now with containers, it's ephemera, right? And so that's why you have distributed logging. But even tracing logs, good luck, right? How do you do? So there's a different ways of doing it. But with OpenTelemetry, you can actually add support where your logs will have a trace ID in the log itself. So now you can all of a sudden look at your trace, logs for a particular transaction. Similarly, the traces, what you do is with the trace ID, you can actually look at the entire call chain across microservices. And they can even be somewhere else. And if you start from the browser, you actually can see the call chain all the way from the browser. I really wish I had the React UI hooked up. If you consume that, now you can see end-to-end visibility of. If a user says this is slow, why? Then you can try to figure out from the call chain which one actually is causing the issues. So the context propagation part, what happens is, in order to keep moving the same, I guess, context, as soon as the parent trace starts, or the parent span, the root span starts, it has to carry some of these things along. That's how it keeps that context across all the way, right? And a lot of, so for example, if you're doing Java, a lot of the Java libraries, like Spring Boot libraries, have native support. So you actually can have spans internally within. So let's say it hits my order service. I'll show you today. Within order service, I'm making multiple calls, but those are automatically captured because those libraries have added support, or with auto instrumentation using the Java agent. It does. In Go, they use like eBPF and stuff like that. So what it essentially does is, like, for example, these headers are propagated along the way. So if you're talking through HTTP, they are carried through HTTP headers. If you go to Kafka, they put it in like message properties. So depending on the protocol, they keep getting passed, and it's the job of the receiving end to actually add, enrich, do whatever it's supposed to do, publish the spans, and then move it downstream, right? So everybody has to like participate. It's kind of like passing the baton. If one person drops it, then you won't see it, right? So sometimes you won't, sometimes something happens. It's because that particular service had some issue, it's not sending the spans, so now the call chain is broken, right? But context propagation, that's what it does. It actually helps keep that context across, and then you get a nice waterfall view of your transactions, right? I'll show you that. All right, so this is kind of like a different, view. So it's actually showing it for HTTP. That context moves across as HTTP headers. All right, so let's talk a little bit about the main building blocks, right? So we already said it's a standard, so it's a specification, and there are some language-specific APIs and SDKs. So, for example, Spring Boot has good support. Node has good support. React. There's a list of languages over there. Most common languages have this SDK, including Rust. And then you have the OTLP protocol. So someone already talked about it, right? So that allows you to. So normally, if you ever worked with like a protocol, that if you want to transport things, you need a Y protocol. That's what it gives you, and so that helps you to have that common data format, right? And then you have the OpenTelemetry collector. So I'll show you the kind of like the architecture. The collector is responsible for gathering these signals, and then there's something called the OpenTelemetry pipeline. I'll show you. That's the beauty of this. So for you can chain multiple OpenTelemetry collectors. There are different patterns for doing that. It's all kinds of fancy things. You can add enrichers, processors, all kinds of things in that pipeline to actually grab the basic signals, enrich it. So, for example, in Kubernetes, there's something called a Kubernetes KH attribute processor. What it does is actually when it comes from when the tracers comes in or the spans for a particular trace comes in, it actually looks up the pod by looking at the pod IP. It looks up all the Kubernetes metadata and adds it as attributes. So that's the job of that little processor, right? Most of them are written in, like all of them are written in Go, and it's most of them I should say, and then you can keep chaining them and enrich your telemetry data as you move along, right? And then from there onwards, you can decide, okay, I'm gonna send this to Randoli, I'm gonna send this to, I don't know, Splunk, I want to send this to OpenSearch. You have a choice. So I think that's one of the key things that I see with OpenTelemetry is it gives the end users, the customers, a choice. You can actually take ownership of your telemetry data before you pass it on to a vendor. I don't want to get into the vendor politics here, but um, the in the past, um, you know, when you scrape the data, the only way you can access that is if you use the APIs. They first ingest you, gotta pay the ingestion tax, right? And then you can use the APIs and other ways to get it. But now, if you are using a vendor for observability, insist on allowing you to use OpenTelemetry, because when you use OpenTelemetry, you have control before you send. So I'll give you an example. Without naming names, we get to some observability vendors. You are charged on a per gigabyte that is ingested, right? Everybody knows that. And sometimes you end up sending all kinds of logs, traces, metrics, and sometimes you don't even want to. But in the past, you didn't have a choice. What you could do is, if you use OpenTelemetry, you can have a pipeline in front, you can massage the data, and you can choose to send only the data you care to the agent before it gets ingested. So you have a choice. So that's, I think, something very important to understand when you look at the pipeline. So this is what I'm talking about from a pipeline perspective. There are receivers. So receivers are, the ones that actually gather data, pulling or pushing, and then the processors do the massaging, and then the exporters are the ones that are pushing out, right? So you have exporters that can push to OpenSearch, Elasticsearch. I think Datadog, Dynatrace, they have their own exporters. Jaeger is one. So like there are, like, you can write your own thing, right? Like export. So you can push. What they do is they have this exporter, so it pushes into the vendor specific way. And there are other vendors who actually what you call OpenTelemetry native. There are multiple, and we are one of those OpenTelemetry native observability vendors, right? So let's break down a pipeline. So if you look at the OTel pipeline over here, you'll see that you have the receivers at the top, right? And now this is the beauty about it. Like you can, if you expose it out as a cluster, applications in your VMs could also push here if you want to, right? So it can ingest from these endpoints from applications running inside the cluster, outside the cluster, anywhere. If you do auto instrumentation, what happens is these collector endpoints are configured in the agents that run in your pod. But otherwise, let's say you want to take control and, for example, in Spring Boot, you can actually, instead of auto instrumentation, you can choose to push to an endpoint. Then you would be pushing to these endpoints, right? And then if you go down, so usually when an endpoint will have slash metrics slash logs slash traces kind of thing. So single endpoint, but you can push multiple. Yes.
So using push, in Prometheus metrics, it's pull, right? Is trace as pushed?
You can do both. So there are, depends on how it is. So if you have the agent auto annotated, it actually gathers the information from it and it pushes to this endpoint. So when it comes to metrics, you can absolutely push to this, but you can also, I think someone asked that question. So with, I believe you can do that with, someone asked support about, can you add support for a Prometheus? So in the OpenTelemetry collector, you have what you call target allocators. So you can actually configure your target allocators to look up your service monitors if you're already using Prometheus. That's kind of like how we support some of our customers because they already were using Prometheus and they want to continue. So you can add support to the target allocators to actually scrape from those endpoints as well. So that's why in the previous one it said push or pull. You can have support for both. But in general, someone's actually pulling and pushing it to this. That's what's happening at the end of the day. Yeah, yeah. Yes, you can if you want from your application. You can absolutely do that as well. But the agent will push. If you have the target allocators, it will do. Also, mix and match. For example, I had an example where I was pushing metrics or scraped, but I was pushing tracers. So you have the option there as well.
This is the only way you can ask application or service, you can ask states, like for resource usage. But application need to report traces, who comes, which request, how fast it's performed, always pushing.
And then we come here, the exporters, again, exported to multiple sources, so that's where you get the advantage. You can expand and you can chain these pipelines to do really funky stuff. And then I don't have a lot of examples here, but for example, here you see the processors. There's a batch process. That's where you can put the case attribute. There's something called span metrics, which I'll show you as well. There's different processes. You can also write your own processes. So, for example, part of our product, we have a custom processor that does certain things, but you can also write your own process. So, processors are a way for you to filter out information. There are some built-in processors that you can use to filter, transform, and do other things, but you can also write your own custom one as well. So, it gives you that flexibility to control how you want to move your telemetry data. So at the end of the day, like I said, OpenTelemetry is mostly about choice. The standard gives you a lot of choice, right? All right, so it's like the big picture with the data sources, and then you push, and then you open total collector pipeline will receive it, massage it, see the batch sampling metadata. So, for example, why I talk about sampling? There are different ways to do sampling. That's a completely different topic. But let's say you're getting 1 million traces an hour. There's no way in hell you can look at it in a screen, right? So that's why you do something called sampling. There are head sampling, tail sampling, different sampling strategies. So sampling is the way to get a representative set of transactions that kind of gives you, because impossible to look at 1 million and decide, oh, which one I should be looking at, right? So there's different ways. There are different strategies to do tail sampling. You can do in memory. There are other things, and we do it in a slightly different way. That's because of performance concerns. But these are the things that you could do. Think about this is all happening before you push to the back end. So that gives you a lot of choice about how much data you want to send, what do you want to do, how do you want to configure. There's this one customer that I know. They wanted to get rid of certain logs, so they're like, and this vendor said, yeah, you can add a filter. It turns out you add the filter once it's ingested into the backend, so you already paid. So this you can do it yourself, right? So there's a lot of flexibility. Yeah. All right. So and let's talk a little bit about the instrumentation approach, because a couple of people ask questions. Kind of eating into my own presentation, but it's fine. I think I'd rather you guys, give this knowledge, and we'll worry about my product presentation later. So there's a couple things. You can do manual instrumentation. A lot of libraries have good support nowadays, which means you can add custom metrics, add custom spans within your code. So let's say you have a method, a very expensive method. You could actually add spans inside that method, so you get a better visibility into how it's taking time, right? There's also profiling and stuff like that as well, but this is another way of doing it, right? Lots of visibility there. And auto instrumentation I talked about. There are so for this, I believe it's for React, and you can add that support. And there are two opportunity like ways, right? So you generally the people who write the code can do the other one. But let's say you already have, I don't know, 20, 30 microservices, 100 microservices running. The DevOps SRE teams can kind of use the OpenTelemetry operator and auto instrument it. That's pretty powerful. Let's say you already have a bunch of services running. Without changing the code, you can auto instrument. That's part of the demos I'll show you today. All right. So the way it works is you install an OpenTelemetry operator. So it different. Sometimes some vendors have their own distribution of it. We try to use as close to the OpenTelemetry operator as possible with some custom collectors that we have. But in general, you end up deploying the OpenTelemetry operator, and then you have a couple CRDs to configure your collectors, right? And then you set up your instrumentation and the annotations, and then off you go. That's it. So this is one of those, just to, because we are Kubernetes Meetup, I just put a couple of CRDs there, what it means. And this allows you to configure, and there are different, and with some of these, so I don't, yeah, this doesn't have the target allocators, but you can add, like I said, add support for like CRDs and stuff like that, right? For service monitor CRDs. All right. So let's do this. All right. So before I kind of show some of the stuff in the product, I kind of want to give you a quick overview of what we are doing, so we have, like I said, a cost management product and observability. I'll only talk about the observability product today. The observability product is, there's a comparison. If you go, you'll see. The cost is huge for a lot of people. And there's a reason for it. So I'll just show you this tweet from, oh, sorry, I'll leave it here if anybody wants to. I'm not the best marketing guy or sales guy, right? But this is a very nice tweet from, well, he's not on Twitter anymore. Kelsey is talking about the cost of observability and distributed or federated control planes. So the way we keep the cost down is not because we do a cheap job. It's because we do more stuff within the cluster and we only pull in the data when you need it. That's a massive savings. So there's this customer that they have a 7-figure Datadog bill, but their monthly egress cost is $30,000. That is related to observability because all the data gets sucked in, right? That's a huge amount. Now you can make it zero, but you can certainly, reduce it, right? So that's where that optimization comes. So we believe in that distributed control plane or the federated control plane, where a lot of the work is done by an agent that's a lot more intelligent, that's running on the cluster and do more decisions. So, for example, log analysis, right? That's a big one. A lot of vendors charge an arm and a leg to get logs, and then people are like, oh, wait a minute, we have sometimes proprietary information. What about security? Oh yeah, if you pay extra, you can sanitize the logs still on the way. So and you end up paying more to actually sanitize your own logs. But we realized early on that there's always a security risk in us consuming your logs. Cost. We also have to store it, manage it, all of that stuff. But what if we do more in-cluster log analysis? We ended up using a Datadog library called Vector. It's a very popular library right now. OpenShift logging is based on that. So we use, it's very fast too, written in Rust. So we do the in-cluster log analysis. That's actually one of the biggest ways we reduce the cost. It's fast because it happens at the source. You can write custom logging probes and analyzers. I'll show you one today. And that runs on the cluster. And we only get certain information. All you need to know is these logs were matched and these log snippets were present, kind of thing, instead of taking everything and then looking at it and saying, oh, something is wrong, right? So that's a huge way to sort of reduce cost. Same with metrics. Now, if you do tracers, there's a cost comparison that I did. I actually ended up writing an article because I realized it's a lot of work. So I ended up putting an article there. If you and there are some scenarios about like nodes, certain amount of nodes, right? But what I was trying to point out was when you start with tracers, you will notice that beyond like the tracers can be pretty verbose, like logs. It will actually consume a lot of data that's going out, right? So tracers. And be careful about those things, and that's also another thing. So a lot, like some people can have millions of traces a day, like some customers, right? And then you only need the day to look at the traces if you actually have a need to do it, but you need it in case. But what we try to do is we keep it closer to the source, and you can see it when you want it. That way the cost of having to send it out and get it curated and managed and stored. Because as a vendor, if I take those, I'll have to, store it, secure it, all of that stuff, right? So we're passing on that savings to the customer and keep the data closer to the source. Yes.
So the data you see keeping it on the cluster itself, so it's not sent out for analysis or processing.
No, it's done. Then most of the analysis is done within the cluster. So there are a couple of options. You can keep it within the cluster itself, or keep it near to the cluster, in the sense it's running within your availability zones, right? Exactly. Yes. Yeah. It can be substantial depending on the volume. So that's a key sort of differentiation there. Um, and then, OpenTelemetry support. So I will show you that demo that I talked about. Hopefully it'll work. Let's see. This one is not having the traces. So this is my node application. So I come here. Let me see if this is. I've got a separate sort of environment for this because I was told don't touch anything else. See, so I got locked out. Yes. And I had to fight to not get spot nodes. Because I find sometimes you do a demo, like suddenly nothing's working because the spot node has got cleared up, and yeah, right. So let me actually first show you this spot. It's a network map, and this is that exact thing that I talked to you guys about, the uh, minus a few pieces. It's probably better to see it over here. That's kind of like this. The order service, product catalog service. So there's like a network map. It's based out of eBPF. So you can see, you can go back in time, and also look at the stats at a given time, because sometimes it's fine now, but 15 minutes ago, 20 minutes ago, something didn't work, or 2 hours ago, or yesterday at 2 p.m. something happened. So for example, sometimes you get complaints, like customers say, hey, I had this issue when? Oh, yesterday at this particular time, right? They log a support ticket. How do you go back? So you got to go back and look at time. And data retention is a problem. So you got to pay more and more. But if you keep the data closer to the source, storage is cheap, and memory and other things are cheaper at the source. So this allows you to go back, so the storage, we provide some storage engine support. So one is ClickHouse, one is actually ClickHouse support is still in yeah, being done. OpenSearch or Elasticsearch, both will work. And for metrics, we are experimenting with Victoria metrics. I'll talk about the difference between Victoria metrics and Prometheus, both open source, but
It's totally different.
It's totally different.
Yeah,
Yes,
on the very beginning on the project, it was similar, but right now it's
very
totally
different. Yes, yeah, they are tuned for different use cases. And with Victoria metrics, the retention is pretty high, accuracy is pretty high. It's nothing. It's not, to your point. We shouldn't say like Prometheus is bad. It's not. It's designed for different scenarios and use case. And so we are having much better luck with Victoriometrics. So one of the newer things that we're releasing will be based on Victoriometrics. So then you can go back even 20 days back and see at 2 p.m. last week, how was your network map? What was your memory, CPU? What was your JVM performance? Right? It's not magic. It's just that you have the data, and there's a cost-effective way of looking at it. Instead, otherwise, you would have ingested 2 weeks worth of data, whether you need it or not, right? Yeah. So there's a network, and we can go back and look into it. So that's that. And then let me go back, and hopefully this will work. I am pumping some transactions, right now, steady state. And let me show you the traces. So this is actually, this stuff is calculated from something called span metrics. So the spans actually have a lot of good information, and using that, we've done some pretty amazing stuff, because they have such a rich set of data. So all of this, for example, this inbound is your API calls coming in. Outbound is when you talk to like product catalog, shipping, all of those guys, right? And there's a latency spike. I'll regenerate this. And then when you click on one of these transactions, you should be able to see the call trails that we talked about, right? And here you will see the entire thing, for order service, not just order service, but talking to product catalog service, talking to shipping service, and then even the Kafka message public. No, if I had my inventory service working, you would see the inventory service consuming from the Kafka message. It will continue the call chain, right? So here you can, as you can see, it actually does a breakdown of all the major call points. Like, so for example, I am looking up product catalog, so I can see the latency to go to product catalog and load it, right? And then, from product catalog, maybe if it is doing something with, Redis, you should be able to see that from there, right? And then, that's the, so if you look at this, see the Redis call. Can you see the tags Redis call? So there it's, so it tells me that from here it went to Redis and picked it up. Redis is like the library for Redis. So it shows you how much time it took to the actual Redis call from order. It does a get endpoint goes there, right? That's that call chain we're talking about. Then the order service writes the database. You see the database query, latency. You can see the database query itself. So a lot of information that is kept within these traces, and you can really see where the bottleneck is. So what I did was, during that high volume scenario, I artificially had a delay in the post call, so you can see like it's 4.6 milliseconds. That's why it's just wrapping it up. But everything else, if you see here, is like microseconds of like very small, right? So and this is how you can debug slow transactions and everything. So this magic comes from OpenTelemetry, and I'll show you the code for this too. Some of you must be wondering how does this work. So look, my order service has nothing. It's just standard Spring Boot, right? And what happens is, I'll have K9. It's probably easier to show here. Yeah, well.
Yeah, that's all. What?
What's that?
Gas?
Oh, yes, it is running on EKS. Yeah.
Okay.
Well, see my or inventory is crashed a bit. It worked until very recently, but something went wrong. Okay, here. So if you see the order service, I'm running two pods here. See, auto instrumented, so it's injected Java agent into this. That's how it gets the traces. So coming back here, like zero instrumentation. No, so the if you for some language, so Golang, there's an eBPF agent that gets in, but Java is a regular Java agent. When you have the annotation, it actually initially runs an init container and injects the agent. So it's an init container, but in Golang, if I'm not mistaken, it is a sidecar, and it does that actually does something with eBPF. Yeah. All right. So this is that spike latency thing. So I have a poison message that, if this is true, it'll end up spiking latencies. So I will let that run and let this go to shit while I'll show you a couple of other things. All right. So here,
The reason why you run it in Asia Pacific South cluster?
cheap.
Latency? Or just cheap?
Yeah. Okay. There you go. I give you the unvarnished truth. So if you are looking around, again, demos, certain things, experiments, there are some regions that are cheap. So not always Asia Pacific is not always cheap. Singapore is actually extremely expensive compared to US East. US East is surprisingly a cheaper region. But there are some. I think the Mumbai data center or somewhere is cheaper. So they should look around, shop around. For certain reasons you can, like compliance or prod, you can know. But there are other things you can. It's pretty good discounts. And then my favorite spot instances, but bad for demos. Like I said, so the customers are wondering, like, is your product stable, man? Like it's not working. And then you see some spot instance when I clean up everything, right? So yeah, but yes, it's cheaper. That's what. So I'm gonna spike some latency and have some fun, but I'll show you a couple other things, right? That's the basic telemetry stuff, but I wanted to show you, someone asked about monitors and alerts, right? Like for example, here, so it's given some latency on P90, it gets triggered, you can get a Slack, email, Teams kind of alert. What actually happens is, I'll probably show it in this one, this environment if it is there. Oh, so I don't disturb this. Oh no, I gotta log in, so screw it. I'll come back here. If I go here, you can add monitors. It's like, we have a whole library of stuff. If you have deadlock, JVM, memory usage, any kind of inbound, outbound latencies, error rates. So, for example, let's say inbound latency, you can give you can say for this particular endpoint, give a percentile and add alerts and monitoring. Pretty standard stuff. If you look at any observability vendor, you'll get a more or less kind of similar stuff. And then yeah, the log analysis is the one I was talking about. So, for example, I'm looking for this particular uh, log snippet, and this is real time. As the logs are produced, you look into this. I can also say that within 10 minutes, if I see this thing, I know it's trouble. Create me an issue. When you create an issue, you get an alert and all of that stuff. So you can configure all of those things. So that's what the log analyzer thing is. And there's another cool feature, runbooks. You can put your runbooks over here, and then we will match it to your issues. So what the advantage is like, if you take an SR team or DevOps team, not everybody is equally experienced. Or you could be an expert on one set. Like if you have 60, 70 microservices, you are not an expert on all those, right? Like there's operational knowledge. So people can create recipes. This is how I solve this problem kind of thing. And then let's say if someone else is on a shift, they get this issue. It's nice to have that run book surfaced to you instead of you looking through all over the place, right? That's what it does for you. So let me go back now. Now these, hopefully the, yeah, well, it's slow, like I said, but latency. And then this will come up. I don't know if I have these issues over here, but I might actually have some of the issues loaded over here. Yeah, see the log analyze issue. So what happens is we automatically detect some of these issues. And if it is there, you see this JVM one gets mapped over here, right? So now the person knows, like, based on that issue, what happens. We have you can see the telemetry report, but also if you can integrate with like a third-party log management system like Elasticsearch, or I mean, some enterprises love paying to Splunk, so we added that support, low key stuff like that. So you can like quickly see the value here is like it will pre-filter for that particular log, and it will actually cake you with the context. So this is like the idea is you get an issue in the middle of the night, instead of going to log management and filtering it, this takes you directly filtered by the workload, could be cluster. So if you configure the integration, it's just making your life easy. That's what it is. So I'll go back over here. Yeah, it does. It does. And in the tracers, I think I showed it, so maybe I'll show it to you when this comes. Hopefully you'll see. I see another climb. So that's the second bump that I just did. So if I want, let's say I look, I feel like chancing my luck here. So let's look at this. You can get a telemetry report. So because JVM and other stuff is inside, right? So I will look at the pods, and then you can see some of the stuff over here. Hold on, give it a second. Oh, what happened? I did something stupid. No. Let it settle down for a second. Let me come back and show you something else. This is low. So there are a couple of other things that are important too. I think Preetham mentioned this. Like, sometimes it's good to know if something is wrong. Did you do a recent deployment? What happened? Did you do the configuration change? So we capture all of that too automatically. So for example, when you're like middle of the night, you have to do a on call, figuring out an issue. Developers may or may not be there, or someone who did the deployment may or may not be there. And then you have to do, instead of doing kubectl and looking through Git logs and all of that stuff, you come here, you can see like, when did you do when was a new deployment happen? It also shows here in this chart. So you can, put two and two together. So, you get a little bit of information as well. And then you change, this is the deployment, this is the image tag. If you change the configuration, we don't do this for secrets, obvious reasons. You could see the diff. So I just changed this to 23. So you know what the diff is. I again changed to back, because otherwise it's gonna crap out the whole service. And there was a crash. So we automatically detect like things. So most teams are very vulnerable soon after a deployment. You don't know if the new one is going to work. So you watch very closely for the first 1 hour, 6 hours, and stuff like that. We actually have the data and the pattern. So we do pattern recognition. So we can say that if you have, sometimes it's not crash or backing off, but it's actually crashing every so often. Some people don't even know because Kubernetes will automatically restart it, right? So your customers are complaining. Because if you're deploying 60, 70 microservices, how would you watch individually? So this will look at those patterns and create an issue and give you an alert to say, hey, something's happening. There's anomaly detection and other stuff as well over here. Let me go back and see if I can get some luck. Oh, no, this is the wrong service. Let me go back onto this one. See if I can have, the other one doesn't have the OpenTelemetry annotation, so that's why I'm worried about. Okay, let's see. Okay, if we are lucky this time, we will, I probably screwed up this cluster by, let me shut this down. Yep. Because some of these things are running there. Okay, so that's, I apologize for that, but let me see. We'll try one more time and see if this, yeah, there you go. And yeah, that cluster is toast. So that's what happens when you're cheap. Uh, but hopefully it'll come back up. And I want to show you because all of those metrics are actually, I'm going to yell at them for, let me see if I can get this working. The demo gods are lucky. I might be able to see it. The idea is like all of these metrics that you will see actually comes from, they work this time, so I'm not going to touch anything. All of these things are actually, so here the C logs for your reference actually now gets filtered by this particular pod because you're looking at this pod, right? See the JVM runtime, see, oh, this is what screwed up the cluster. So there's a big pile there. And network, CPU, these are all actually coming extracted from OpenTelemetry. And instead of doing anything fancy, this is the JVM metrics. Again, what happens is Spring Boot exposes them in the JMX format. Prometheus has a JMX, so JMX is the Prometheus exporter, right? And if you have a service monitor, we can automatically scrape it. Or actually in Spring Boot, though, you can configure the micrometer to push it from the JMX. So both options are there. You can see the data and then you can figure out, and then you get, so if you click on an individual trace, you can also navigate to the logs filtered by the trace ID, those kind of stuff, and then, we kind of go and debug. And there is anomaly detection and other nonsense. Like, so sometimes what happens is, you suddenly certain things happen and you have no idea why or how, unless you're paying attention. Like recently there was this one customer who migrated from one version of database CockroachDB to another, no code change. Suddenly, a query that used to return 10,000 records started returning a lot more. And then if you have a spike, you can see that. All right, good. All right, so now, yeah, good. All right, so I'm going to wrap it up. If you have any questions, I'm around. I'm happy to answer. Thanks for your patience and all the questions so far. It's a pleasure to be speaking here, and thank you very much. Let me get out of this one. And I'll say,
Keep you till late, but yeah, I really appreciate you guys taking your time. Allow me a moment, please. There we go. So please scan the QR code on the screen. I'll wait for a couple of minutes.
Please talk and.
Yes, sir. That's a nice observation. Thank you. Good to go? And meanwhile, if you have any feedback, please let us know. We are always open to feedback. Even if you didn't like it, we will be receiving the feedback and we'll improve on it. And yeah, we have got top five winners of this quiz will get some surprise giveaway from us. So try to be at the earliest and answer the most correct from all the questions. So yeah, to increase your chance to win. There you go, emergency. And one more time, if you have some use cases to share, if you want to speak, feel free to reach out to us and we'll be more than happy to give you the stage in one of our events. I'll still wait for a couple of minutes and then I'll start the quiz. So when I start the quiz, it might ask you to enter your name and it will just hang up. But until and unless I'll start explicitly from question 1, you won't see anything. So yeah, that's how this platform works. Start the quiz. Still wait for a couple of more minutes to join people. Yeah, I see 4 people joined. There we go. 22, nice. I like it. 33, okay. Okay, now we are talking. 38. Last a couple seconds before I start. Anyone?
We have the ops here. I need the smaller latency on my phone.
Yeah, there is a public Wi-Fi. And I'm gonna start the quiz now. The first question. Which one of the following is not the one of the 3 pillars of observability? Logs, traces, alerts, or matrix? Okay, 85 is not a bad number. Second one. What is instrumentation in context of observability? A rock band, white box monitoring, automatic cluster upgrades, or 99.99% availability? That's correct. That's correct. Oh, we still have someone to vote for rock band.
Sorry.
Well, maybe you don't want to win. Which AWS service helps visualize request traces across distributed systems? Amazon Detective, AWS Amplify, AWS CloudTrail, or AWS X-Ray? Hard to guess.
I'm silent.
All right, that's the X-Ray, sorry. Fourth one up. What does CloudWatch Container Insights collect? The number of memes shared for the day, container IDs, matrix and logs from the containers, or number of pod restarts?
This is my calling. This is not this.
Okay, 95, not bad. Fifth one. What does X-Ray SDK automatically trace? Grafana dashboards, your internet speed, IAM policies, or AWS SDK calls, HTTPS traffics, and the queue operations within X-Ray? All right. What's the key benefit of using ADOT, AWS Distro for OpenTelemetry? No need to build dashboards. It enables secure production-grade telemetry collections on AWS. It replaces DevOps engineers with AI. And the last one is, it automatically finds the developers who fixed or who broke the production. Well, I wish there was some open source tool around it, but okay, 97. Okay, not bad. Everyone is winning, so it's a matter of time, I guess. What is a metric in CloudWatch terms? It's a life journey of a pod, It's AWS's way of billing us.
Yes.
That's some inside info. The third one, it can predict the outages before it happens, or the numeric data over time intervals. Okay, short. There we go. You got it right. There comes the eighth one. What is OpenTelemetry mainly used for? Collecting, processing, and exporting telemetry data like metrics, logs, traces, real-time video conferencing, writing logs directly into some blockchain, or it detects the bad code and emails directly to your boss. Oh yeah, pardon. I was in a rush while I was creating this. Sorry. Oh, 100%. Wow. Awesome. People were really preparing and giving their time to the presentation. The next one. What's a common way to deploy the OpenTelemetry collector? By screaming at your terminal, just like I'm screaming right now. Or reach out to AWS customer support and get it installed. Or copy paste commands and just hope it works. Or as a sidecar or a daemon set or a standalone service. I wish. All right, we have got only 2 left. Let's see. What makes OpenTelemetry vendor neutral? It works with any backend services like Prometheus, Jaeger, Zipkin. It avoids brand names to attach to it. It refuses AWS for billing, or it always picks Switzerland as its default region. Sorry, last one was really out of context, but I was short of options. Okay, that's good. And the last one, let's see. What is span in OpenTelemetry? A single operation within a trace, SDK, the time it takes to explain observability to your boss, or models to configure security on Kubernetes cluster. And I forgot to mention one more thing. If you have previously been a winner of these quiz, please leave us and give other people a chance to follow you. There you go. I'm gonna end the quiz, the leaderboard. All right, top 6 people, congratulations. Oh yeah, then 7th one. Yeah, big round of applause for the winners.
That is all. Hey, who was the winner already?
Third one. That's so honest of you.
Basically, we have for top 3 the core cloud subscriptions.
I have that already.
Okay, but then you can choose the book if you want one of them.
Okay.
Is there number 7, so you have to expand the list.
We'll get something for you for sure. All right, thanks a lot. Another round of applause for the speakers. Get the time, and I hope you guys enjoyed it. All the winners, please stay here and give your information to us so that we can facilitate the giveaways. And yeah, that's it. Thanks a lot, and thanks for joining. See you next time. Goodbye.
Thank you.
Thank you so much.